Good morning. I'm going to make a video for the homework for chapter 6 to help. But the first thing I'm going to look at, let me show you right fast. So when you start dealing with probabilities, you can start dealing with really small numbers. So one thing that you might be seeing in the calculator is if you do a scenario and you get a number like this, 3.56767 e to the negative 6. Okay, remember a probability cannot be greater than 1. So if you put 3.56, you would get the question wrong. What this means is 3.56767 e to the negative 6 means you need to move the decimal places 6 places to the left. So my decimal place started on the right side of the 3, and if I move it 6 decimal places to the left, this is the number I get. 0.000035676767. And let's talk about that. This, I'll put it down here, is a decimal. Okay. What if it was asking for a percentage? So then what you would do is how do you make something a percentage? Well, you're going to move, so this is a decimal. So to get a percentage, you move the decimal 2 places to the right. So this one now would be 0.000356767. And if they're asking in WebAssign for 4 decimal places for the percentage. Oops, let me put the percentage behind here. Oops, there you go. It would be 0.0004 is the percentage. So remember, in the calculator, if you get like a 3.56 when you're doing probabilities, go see if that e to the negative number is down there. Okay, so let's go ahead and look at the homework. All right, so I'm in 6.1. I'm going to make this bigger. All right, so the first question for 6.1 is so it's looking for the median recovery time. All right, remember the median recovery time equals the mean. So you need to find how many days that it would be that the median recovery time would occur. So try that. Okay, number 2, you're solving for a z-score. Remember, the z-score equals the data value minus the mean over the standard deviation. Be careful when you put that in the calculator, and I would do it in 2 steps. The first thing I would do is data value minus the mean, enter, and then take that answer and divide by the standard deviation. So number 3, this one's a tough one because we really didn't talk a lot about uniform and distribution or even exponential. This one is exponential. Why? Because the mean of 5 minutes and the standard deviation of 2. And in a normal distribution, the mean wouldn't be significantly greater than the standard deviation. It wouldn't be the same in uniform. It would be an exponential, because exponential, the rate increases substantially as we go along through time. So number 4, all you're going to interpret is, what does the z-score of 1.75 mean? So if you're having trouble with that, go back and read the book, because it has to do with the place of 1.75 on the normal distribution curve. So think of it in terms of the z-scores, not with the mean and the standard deviation. Okay, for these are, you're just going to keep finding the z-scores. And this, all you do again, the z-score formula is data value minus the mean over the standard deviation. And if you're having trouble with this, again, go back into the book and read 6.1. It should be able to help you. And here you're just going to select, is the standard deviation above the mean or below the mean? And how are you going to know that when you do a z-score? If it's below the mean, it's negative. If it's above the mean, it's positive. Okay? So that is 6.1. So let's go to 6.2. All right, so 6.2. This one's a little bit trickier. All right, so for number 1, anytime I'm talking about a percentile, that's going to be an inverse norm function. If you're like, I don't know what inverse norm is, you need to go watch the videos. I even have examples where I show how to do the inverse norm function. So for number 2, it wants to know, is there unique values outside the range? So if you have a mean of 6 and a standard deviation of 2, would it surprise you if something took less than 1 minute to find a parking space? What you want to do is use the normal CDF function. Yeah, use the normal CDF function and see what that percentage is. Now for here, it says 80% of the time it would take more than how many minutes to do. Okay, so this one is inverse norm. So 80% of the time it takes more than how many minutes to find a parking space. You need to think of it as 20% if you want 80% more. Does that make sense? So if I drew the normal distribution curve, I want to know 80% of the time it takes more than how many minutes. So if I have 80% on the right half of the normal distribution curve, what's left on the left is 20. So you're going to do the 20th percentile, or 0.20, in the inverse norm formula. Now for number 4, you're going to write, for part A, you're going to write the normal distribution as you see it in the book. If you're confused, again, go watch the videos. I explain how to give the distribution of X. You really want to get this now because as we keep going on, we're going to have different distributions. For part B, this is a normal CDF function, so you're going to use your calculator. For here, you're just going to pick out the graph that best describes it. So you want to see this is fewer than 180 feet, so you want to pick the one that's fewer than 180 feet. And then for part C, then you're going to do the 80th percentile. Again, this is an inverse norm function, so you need to be careful and look at this one. And then for here, you're going to write the probability statement. So go ahead and look at this and see. I talk about it a little bit in the PowerPoints, but it's definitely in the book. So number 5, all right. So A, you're going to try to determine how we're defining X. So you need to think about it in terms of which statement is true that we're looking for X. And if you look up here, this will help give you a key. All right, again, you're going to write it as the distribution. Remember, this is a normal distribution. Here, write the probability statement. All right, so here you're going to write that probability statement. X is something to the number. And then here you're going to solve using the normal CDF, and you're going to find the correct graph. Again, go through the PowerPoints, watch the videos, and it will help you. Okay, for this one, this is a normal CDF, but there is a catch on this one. There's a percentage sign. You're going to get the value out of the calculator using the normal CDF function, and it's going to be a decimal. You have to convert it to a percentage. Now remember, I showed you how to do that right here, okay? So you should know how to do that. And then for part E, it's the inverse norm function. Why is it? Because I'm talking about 90% of the children. So you're going to use the 90th percentile, and you're going to plug in the mean and the standard deviation. Now, this is a brief overview of Chapter 6. I'm making the assumption you've watched the videos, you've read the chapter, because if you just try to do this without reading it, you're not going to do well. And this will be on the midterm, so you really want to look at this, or from our face-to-face class, this is going to be on the next test.